Hey everybody, today's lesson is just playing around with the relationship between perimeter and area, and being able to figure out like if my rectangle has a perimeter of such and such a value, then what are the possible areas of it, or if it has an area of this value, what are the possible perimeters, and just kind of back and forth, and understanding that one area, so if I've got an area of like 24, well, is that rectangle 2 by 12, or is it 6 by 4, or what is it? And being able to figure that out. So, let's take a look. Okay, the first thing that we want to make sure we remember is just factors, because that's really what we're dealing with here. When you're trying to figure out what numbers we would multiply together to get a certain area, you're just asking basically what are the factors of that number. So let's just remember what factors are. Numbers that can evenly divide into a larger number. We could also think about that as the numbers you would multiply to get a larger number. So you're either dividing or multiplying to get that bigger, you're going to divide that bigger number, or what numbers can I multiply to get that bigger number. So if we think about that, let's just look at the 32 first. What numbers can evenly divide into 32? Well, let's see. I know that 8 does. And I know with that 4 does. Okay, let's see, 16 and 2, and always 1 goes into a number, and 32. So 32 divided by 32 would get you that 1. I don't think there's any others. So those would be our factors of 32. Let's think about that again with 18. Except let's just ask this the other way around. Rather than saying like we did here, what numbers would divide into 32 divides by 8, 32 divides by 4. Let's just ask here, what numbers can I multiply together to get 18? So right off the bat, we know that we can do 1 multiply 18. Because 1 is a factor of every number. And if you think about it, 2, it's an even number, so 2 is going to go into that. 2 times 9 would multiply. 3 times 6 would multiply to get that. And I believe that's going to be it, because 4 does not, 5 does not, 6 does not, 7 doesn't, 8 doesn't, and then we're back to 9. So those are all of our factors of 18. Again, these are our factor pairs, or if we want to think about that as a rectangle, those are our length and width, if we start thinking about these numbers as a rectangle. So we're going to start thinking about a rectangle that has an area of 12, and we're just going to create them. So what I've done here is just created each of these groups of squares has 12 in it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I purposefully did not arrange them in any sort of rectangle because I wanted us to play around with it a bit. So if I just take 1, and then I line that up even, okay, so with those 12, we can start with our factor of 1. So I could build a rectangle that is 1 by 12. Just finish dragging all of these down there. Sorry, this takes a minute to drag 12 boxes. So I can start with a rectangle that's 1 by 12. And for the purposes of something that I'm going to do a little bit later, I'm just going to group that all so that's now one shape. Now think about it. What other numbers can we multiply to get 12? 12 is divisible by 2. So how many groups of 2 do I need to make? 2, 2, 2, 2, and 2. So I end up having 6 groups of 2, which would make me a rectangle with a length of 2 and a width of 6. And we'll just get all of those scooted down there again. And again, for the purposes of something I'm going to do here in just a minute, we'll group all those together so they're all one shape. there is one more. What else is going to divide into 12? Okay, hopefully you're thinking about the old 3 times 4, which gets us 12. So we want to do them in groups of 3. I wonder if it works quicker to get them into the groups like I did with the 2. Then I'm not dragging quite as far. Struggling to line that up there. Okay. And one more. Okay, so we've got 3 by 4 there, and again I'll just make it as 1. So now I've got a rectangle that's 3 by 4, I've got one that's 2 by 6, and I have one that's 1 by 12. Remember with our factor pairs, okay, if this is 1 by 12, the commutative property of multiplication tells us that that could also be 12 by 1. Or if this is 2 by 6, okay, again, we can rotate that. And now it's 6 by 2. Or if this is 3 by 4, again, that commutative property tells us that that can rotate. And we now have a rectangle that is 4 by 3. So those dimensions would work to get, any of those would get us a rectangle that has an area of 12. But they would all have different perimeters. Because if you think about it, this one is 1 by 12 by 1 by 12. 12 and 1 is 13. 13 and 13. So this one has a perimeter of 26 units. This one is 2 and 2 by 6 and 6. 6 and 6 is 12. 2 and 2 is 4. So this one only has a perimeter of 16 units. And then this one here being 4 by 4 and 3 by 3. Suddenly we reduce even further. 4 and 4 is 8. 3 and 3 is 6. 6 and 8 is 14 units. So the closer to a square we get, the smaller the perimeter. Although they're still all the same area. They're still all made with 12 bricks, but their perimeter gets smaller and smaller the closer it gets to a square. Okay, so let's think about that. We've got 9 square units. So if we thought about that, hey, what are different ways, different things we can multiply together to get 9? Okay, 1 times 9. Okay, would get us 9. What else? Good. 3 times 3. Now if you think about that, 1 and 9, so if I've got 1 and 9 and 1 and 9 around a rectangle, that's 9, 18, 19, 20. That one's 20. Or if I've got 3, 3, 3, and 3, suddenly that has a perimeter of 12. Okay, same thing here, 14. What numbers can I multiply together to make 14? Or what numbers evenly divide into 14? Well, its dimensions could be 1 by 14, or it could be 2 by 7. So if we had 14 by 1 and 14 by 1, suddenly we have 15, 15. So that would be a perimeter of 30. Whereas 2 by 7 and 2 by 7, if you think about that with those rectangles drawn in there, now we've got 9 and 9, which would only be 18. So they have the same area, but they have different perimeters. So really this whole lesson is just about understanding that relationship between perimeter and area and how the same area could yield us different perimeters. Let's try one more. 16 square units. Okay, so we'd have the obvious, because 1 goes into everything. 1 and 16. What else? It's an even number, so 2 and 8. Okay, there's one more. It's a squared number, so that we could make a square out of this. What number multiplied by itself would get you 16? 4 by 4. So 1 and 16, if you think about that, 1 plus 16 is 17, and 17 plus 17 is 34. So this one would have a perimeter of 34. 2 plus 8 is 10, and then 2 of those would be 20. So the 2 by 8 would get us a perimeter of 20. And 4 plus 4 is 8 times 2 would get us a perimeter of 16. So again, all the same area, but they yield us 3 different perimeters. Let's go ahead and finish this off by just taking a look at a story problem that we might have to deconstruct as we work through this, and then I'll let you off onto the lesson. Danica has laid out floor tiles so they form a perimeter with a rectangle with a perimeter of 18 inches. What is the greatest and least possible areas of the rectangle? So think about that. The perimeter equals 18. Okay, so if I draw one that's 1 here and 1 here, that takes us down to 16. So these two sides, what plus itself equals 16? So I've got one that's 8 and 8. That area, that would be an area of 8, because we're going to do the length times the width, 1 times 8. Okay, another perimeter that would get us 18. Let's see, if we do 2 and 2, that's 4, so that would be 14. So 7 and 7. 2 times 7 would get us an area of 14. What about 3 and 3? 3 and 3 would be 6. And then 6 and 6 would get us 12. So 12 and 6 is 18. So 3 by 6 gets us an area of 18. Are there any more? What about 4? If I draw a rectangle that has 4, so 4 would be over there. So 4 and 4 is 8. That leaves us 10. So we would have 5 and 5. So 4 times 5 would get us an area of 20. The next thing you know, we're basically to the point now that we're just rotating these. So suddenly I'm dealing with a rectangle that's 5 by 4, or 6 by 3, or 7 by 2, or 8 by 1. So our largest area for a perimeter of 18 would be 20, and our smallest would be 8. So again, we're just going to kind of manipulate these numbers to understand that one perimeter, like that was a perimeter of 18 for all of those, but that gave us 4 different areas. Or one area could get us a lot of different perimeters, and just understanding the connection between those. As always, if you've got any questions, you can watch the video again, or don't hesitate to reach out. I'm here for you.